workshop. This workshop's been set up with Sean, Adela, Penny, and Brian, who are the core of the FAIMS Project, a national project to, well, I guess, develop some integrated archaeological information management systems. The workshop over the next couple of days is to familiarise everyone with the system, with the aims of the project, and also to do some hands-on workshop development of projects and play around with the apps as well. So without further ado, I'll hand over to Sean Ross.
Thanks, Andy. So thanks for having me up here, and I'm happy to see so many of you made it at 9 in the morning. I'm going to have to call, talk to Heather Burke and Mick Morrison at Flinders because the turnout wasn't nearly as good. You shamed them as far as who was actually able to show up on time. So no, we've been doing, UQ is one of our major partners on this project. You guys have been part of it ever since we started the project through the National Research Collaboration Tools and Resources program that is just winding down now. That was our first sort of stage of funding of our project, and UQ was a partner on that. And then you're our largest sort of contributing partner on the ARC LEAF infrastructure equipment and facilities grant that we have now. So. And you're doing some of the development for not the mobile part, which I'm going to be kind of focusing on today, not the data capture part, but on some of the other aspects of the system. And that's something that I'll mention in passing today. And if you've got any in this little intro that I'm going to do now, and we can. I'll try to save some time at the end of this hour for questions. We can talk about other aspects of it. I'm kind of focusing on the mobile data capture part of our system because that's what's the most relevant to what Jess and Andy are doing, so that's the focus of my presentation this morning. I'm just going to do most of this workshop isn't going to be me or Penny or Adela talking at you. That we'll be doing a lot more hands-on things. But I thought that it would be worthwhile to start with just sort of an overview of the project, what we're doing. This overview has been developed in large part in response to misconceptions or questions that seem to us sort of odd questions that we've gotten to get everybody on the same page as far as what the way that the application works, and getting to that a little bit about how it's developed. I'll be talking about some of our design decisions, why we do some things but not other things that aren't always obvious to someone that's hasn't had to wrestle with software developers for a couple of years. Some things that seem to us like should be really, really easy end up being rather difficult or precluded by the, by the devices, by the operating system, by our by the environment that we're developing in, and whereas other things are much more straightforward. I'll also try to say a few things sort of about what to expect in the future, in the near future, with what's sort of possible not only with our software, but the mobile device space is developing very, very quickly, of course, and there's going to be some things that we can't quite do yet that we will be able to do in the near future. But this presentation shouldn't take an hour, and hopefully at the end of it, if there's anything that isn't clear, we can talk about that. So. What we've started with on our project is we wanted to in a way look at how we capture data in the field and take advantage of the new opportunities that were offered by modern mobile devices. I mean, some of you may have used ArcPad in the past, like the ArcGIS extension for PDAs. And that's a lot of archaeological work still uses that, but we thought that the newer post iOS, post Android mobile devices and operating systems were offered a whole new range of possibilities. At the beginning of the FAIMS project, after we won our Nectar award, the first thing we did then was to take a step back and talked to a lot of archaeologists and a few technical people, and we had a big stock-taking workshop at the University of New South Wales. And we had gone into, when we look back at our original application, to the National Research Collaboration Tools and Resources project, we had thought that, and through our initial sort of sounding out of the partners on that project, we thought, okay, look, we'll figure out for excavation, for surface survey, for lithics recording, for ceramics recording, we'll figure out a basically sort of stable core of information that we all want to record about these things, and we'll make a nice sort of slick, good interface, good features, as much automation as we can, data logger, something that's relatively static but really sort of slick, easy to use, like I say, good interfaces, lots of automation, this sort of thing. And what we found, what emerged, very strongly from this initial stock taking workshop was that no one could really agree on anything. I mean, we broke people up into working groups on different things, and this was sort of when we sort of somehow this picture sort of like when we were talking about, well, let's come up with standard, what do we all want to record about excavations? And we'd always thought that we'd make this extensible, that if we could get an 80% stable core and a 20% that needed to be customized, that we'd make essentially an extensible data logger this way. And it just became clear by the second day of the project that there was no way that archaeologists were going to agree on an 80% stable core of like how you were going to record a lithic. That was a very hot topic. That I think that that was the one person that stormed out of the workshop and said they never wanted to talk to us again. Was in the lithics group, but it
wasn't Chris Clarkson.
No, I don't know who it was. But anyway, so what became clear was that archaeologists wanted a lot of power for customization, flexibility, both of the underlying sort of structures of the data and of the interface. So the interface essentially reflects your workflow. What do you do first? What do you do next? What do you record? And so now when we are discussing our project with clients, partners and colleagues, it seems complicated, right? And there is, we'll admit right up front, the cost of the flexibility and customization that we've built into it is that there is a design phase. That if you have a project and you want to use FAIMS software for it, it requires you to think about your data, think about how you want to record your data, model your data, which is kind of a specialized skill and not something that that archaeologists are routinely trained in. So you have to think about that, and then is some combination of contributions from you and contributions from us. We actually have to implement that data model into the data schema, the actual structure of the data, and your workflow into the interface. And it's really a trade-off here, that we could have made a data logger that required very little setup, very little customization, but then the vast majority of archaeologists would have probably been pretty unhappy that it doesn't reflect their own conceptions of the material and the information that they're working with, and it doesn't reflect their own workflows. So we've gone to the other end of the spectrum instead, and we have something that is really, really flexible. We can support however you conceive of your data, and whatever workflows you have, we can support it. It's generalized and arbitrary, is what the developers call it. To the extent that we're now also starting to attract interest from other fieldwork disciplines. I mean, I would have thought that the ecologists would have had a lot more resources available to them than we do for developing things like this, but they're actually coming to us and asking us to do implementations for ecology, and I've got an oral history project that wants to use it for for managing their interviews that they're going to do, and it's got quite broad applications now. So we have gone to that sort of end of the spectrum, is that it's quite customizable and flexible, but on the other hand, then it takes a certain amount of you have to put in the effort to do the customization for it. So that was our first sort of major design decision. And we have I think, implemented it in a way that says that's as painless as we could make it, but it still does require some effort to customize it. So the system itself, and I'll talk more about some of the components later. And this starts now getting into some of the promise and limitations of the hardware and software that we're using. We decided to develop in Android instead of iOS because Android's much more open. It's much more, it's a lot more flexible in a lot of ways, and partly as a requirement of the grants that we've won, and partly because of our own sort of philosophical predilections, we've decided to develop everything open source, right? So, anyone who wants to can, look at our source code, download it. We're trying to encourage projects, and with some success, we're trying to encourage projects, say in the United States, if they want to develop, mobile applications for data capture. We're encouraging them. We've spent a ridiculous amount of money developing this. Join our project instead, and they can essentially, they have access to the source code, and they can extend it, and then they can request that we incorporate those extensions, developments, improvements that they do back into the core code base. This is a common way that open source software works. So, and this open source development paradigm works better in Android than it does in iOS. So we're using Android devices. They're also less expensive, and they come in sort of wider ranges of features and more different flavors of hardware and of hardware. So with that, what we found was one of the design requirements was that if you take teams out into the field, right, you're going to want multiple people using devices, and you're going to want to sync all of that data later. Now, how many of you have used ArcPad and are familiar with it? So ArcGIS, ArcPad. Okay, I will refrain from using too many comparisons with ArcPad. Then that's in as much as as archaeologists have done digital data collection in the field in the past, it has typically been using often Trimble equipment, Juno devices, things like the Trimble equipment, which is essentially a PDA. It's a glorified PDA. So it's a very sort of late 90s, early 2000s technology. But that syncing your data in ArcPad and ArcGIS, it's gotten easier now. It used to be a real pain. But it was, and we didn't want to have ours be that difficult. And I think one of the successes that we've had with our development is that you don't have to think about syncing data. You go out with as many devices as you want. Everyone collects their data. You come home at the end of the day. You hit a Wi-Fi network and connect to a server that can either be a local server or an online server. We'll talk more about that later. And all of the devices will sync with the server and with one another. A few years from now, or say 2 to 3 years from now, we may not need the server, and we initially tried to just do what's called a mesh network amongst all of the different devices, so they would communicate directly with one another. Again, just to simplify the whole hardware and configuration issue, but it's just not ready for prime time yet. It's coming down the pipe for Android, but it's not reliable enough yet to do it that way. So we're still using a client and server architecture with the mobile devices or clients. You go out, collect your data in them, and then you come back and you come back to your base and you hit a server. With that, I will just other non-negotiable requirements for the devices that I think we have accommodated successfully is you can take the devices and they will work offline for as long as you need to collect data offline. We have projects that we're working with who work up in the high Andes, and they may go for like 2 weeks without having access to a computer or a server or anything, so they just all go up with their own devices and collect data for 2 weeks, and then when they do come and hit server, then everything will sync. That gets if you wanted to run a project like that, I would talk to you about how to back up the data on the devices itself. But luckily, devices that take removable SD cards, we haven't fully automated the process of saving your database, your local database to the SD card, but it's relatively straightforward using a file manager. It's like in Windows or OS X or whatever. That I'll get that again in a minute when I need the next slide. It's just a matter of copying a single file across to an SD card, and SD cards are surprisingly durable. I was just reading in the news a few days ago, someone had lost a camera overboard on a boat that when they were boating, and the camera was found 2 years later, and they were able to, and the people who found it just pulled out the SD card and read the pictures off of it. The camera had turned into a little miniature coral reef, but the SD card was still intact and readable with no with no special forensic software or anything like that. So having devices that take SD cards, if you're micro SD cards, if you're working in a really remote location, that's an option. But yeah, the software, it doesn't care how often it gets online. When it does get online, it will sync. And by online, I mean either with a local network. And I haven't actually seen a whole FAIMS in the box yet. Andy and Jess can show off we've just started working with a hardware company to make a pre-configured portable, lightweight, low-power portable server and tablet and wireless access point kit to take out into the field. And you guys were the first people who got one, so I hope it isn't too buggy. Is
that good or bad?
Someone has to go first. You're doing a great service to your colleagues elsewhere by being the guinea pigs for it.
Can I add something to that? Because I've been in communication with Dave on most of that hardware stuff, and it's kind of interesting to see your understanding of what it is that we need, obviously, compared to a hardware person's, sort of understanding. Because I remember asking for SD cards, and he said, "There's no point. You can't order SD cards because you can't back up to SD cards." Obviously, because you can't automate the backup.
It's not automated.
Therefore, it was inappropriate. And the other thing is that he had no idea of what it was archaeologists actually. He imagined us all sort of beavering away in a lab or something, or on a on a coliseum, something like that. Where we'd all be in wireless range of each other. And so when I told him, no, these will go out on survey in lots of projects and then have to come home, he was like, wow, okay, well, I hope they've considered that.
Yes, we have considered that from the very beginning. I mean, this is again, this stock taking workshop we did, and we're trying to write all of this up so that when we started this project, it was shocking. We knew that there had been other projects for archaeological information management system since the early 90s, right? Including ones that were focused on mobile devices, but finding information about those projects, what design decisions had they made, what had worked, what hadn't, why had they all died? I mean, there's only, we were just invited to join a National Science Foundation project out of the University of Chicago, and this project, much to their credit, they're not trying to build any new component software. They're trying to tie together all the existing software. This is something that, some of the Nectar projects in fields that had a longer history of digital work, like linguistics, they had projects like this called virtual laboratories, where they would tie together a bunch of different tools into a single sort of online system for information management, and we're a few years behind. Like archaeology as a discipline, I think we're ahead of most of the humanities and social sciences, but we're a little bit behind the linguists on this. And what the linguists were doing here with their Nectar virtual lab, where ours was classified as a quote-unquote e-research tools project, where we're still building the components that would eventually go into one of these integrated systems. Now what Chicago is proposing is to start tying all these things together. And there's only one other mobile system besides ours, and it's one out of the University of San Diego that's rather different from what we're doing. But we knew there'd been all of these attempts to build mobile systems, to build other kinds of information management systems for archaeology, and you'll find a journal article about it, but then no and they've just disappeared. And we're trying to document everything that we're doing and make that available, give it, give everything DOI, digital object identifiers, so that persistent URLs, so that people can come back and look at it later. And the stock taking workshop was absolutely invaluable because it was laid out. It emerged over the course of the 3 days very clearly. The non-negotiable demands of archaeologists. And of course, I mean, Adela and I do field work in Bulgaria, so I mean we have. And we've done survey and excavation, and we do a lot of ceramics processing, less lithics than ceramics, but we have some firsthand experience with this, but there was no substitute for getting 50 archaeologists together for 3 days. It was a lot of fun to do anyway. But so, and another one of the design parameters that emerged from that is that yes, archaeologists work in remote environments. They work where they're offline, and even Adela has written up a preliminary paper that's part of what we're publishing in the CAA proceedings. It should be coming out any day now. She reviewed existing, for instance, mapping software, and there's very little mapping software for iOS or Android that works very well offline. I mean, some of them you can cache maps. Like I'm talking about like georeferenced TIFFs, say satellite imagery or aerial imagery, and you want them georeferenced so that you can pull them up on your device and see where you are, and and a cursor or a reticule comes up where you are, showing your location. Essentially a mobile, let's call it lightweight GIS, mobile, for mobile devices. Almost all of them assume an internet connection, and even the ones that let you cache, they kind of figure, well, you'll lose your mobile signal for a few minutes, and you can cache, and then you can go on, but then you'll pick up a signal again. That they're not really meant for, they're not really intended for long-term, use offline. So we actually engineered well, we didn't start it from scratch. We developed we signed an agreement with the one company in the world. Most of the basic things that you'd expect from ArcGIS, so layers, rasters, vectors, the ability to load in tiled vector images like satellite imagery, and locate yourself on that, and then draw vectors on it. They're a commercial company, but they agreed to, I think, a very reasonable cost, license us their code, and as long as we sort of watermark the code so you can see where it came from, they're allowing us to distribute that as part of our open source package. Something else, again, looking towards the future, they have an extension to their code that actually handles three-dimensional volumes. Like right now, it's GIS, it handles three-dimensional surfaces, so it's a little tricky using it for excavations, because as you go down, you'll just see context sort of overlaid on one another as if you were looking down on as a plan. But actual 3D volumes, it's coming. It'll be here. I think it'll be ready for prime time soon. So that's something that the other mobile software that they're developing out of UCSD, it has to be online, but it will handle 3D volumes. So I mean, they've taken some different design decisions. So anyway, I didn't mean to quite get so distracted with some of these, but this stock taking workshop was really, really useful. But back to the main thing. So customization. Mostly what I mean, a lot of this presentation is to, I don't know, it's expectation management in a sense we get. And if you saw at the beginning, the title of this project was I'm in the field, send me your app. We still get that like quite a bit. That I'm actually from archaeologists who are out of their field base. They're starting in like 48 hours, and they want to they want the application. And we have to explain to them that you've probably got a 2 or 3 month lead time in development. Most of that is data modeling. It's actually taking your paper forms and thinking through what you're recording and what you want to get out of the data at the end. What kind of analyses do you want to do? What kind of reports do you want to do? And making sure you can get out at the end what you want. It's this process of going back and forth, and Andy and Jess we've been doing that with them. I came up here in January and we started the process, and then we've been in contact with them regularly since then, and very intensively over the last few weeks of first making sure that we have the data models right, and then actually taking the data models and programming them into the system is taking less and less time, where that's one of our goals for this stage of our development, is to get that development, the actual development time. Once you have a data model, how long does it take to actually code it into the application? We've got that time is coming down pretty quickly, largely because we can reuse previous work, which I guess I should actually explain right now. Essentially, what we have done on the mobile, on the device, is the underlying software that sits on the device is an interpreter. It expects you to feed it a series of documents, and then it will produce the application, including, if you specify it this way, the mobile GIS that we have with the layers, rasters, vectors, and whatever kind of vector drawing you want to be able to do on it. It specifies that. It specifies the layout of your user interface to record all of your what we might call structured data. The stuff about the fabrics of ceramics, or the recording of lithics, the recording of excavation contexts. These sorts of things. That kind of structured data. It also specifies when and where and how you want to capture multimedia, like using the internal camera and microphone on the device. When do you want to take a picture? When do you want to record audio? When do you want to record video? It specifies how that's all laid out, and how the data, the underlying data, is actually structured. And to do that, it takes a series of documents. And 3 of the 4 documents are actually pretty human readable, and that we've gotten to the point now where 3 of the 4 mere mortals can edit and produce these, but 3 of them are 2 of them are XML documents. 1 is a plain text document. Our bottleneck that I still have to admit to is the what we call the logic file. This is what drives the application, and that's the one piece that's still it's a simplified version of Java. It is actual programming for that. It only takes, for a relatively complex module, it takes a couple hundred lines of code to drive the whole module. So again, we're getting this development time down as much as we can, but that's the part where you still need some specialized expertise to do it. And that's something that our project can do it for you, or if you've got local resources, you can. One of the advantages of doing it this way, as opposed to, like I said, I'll stop using the ArcGIS, ArcPad analogies too much because not that many of you have used it. But if you develop a geodatabase in ArcGIS, it's not that trivial to redeploy it to another project. This one, what we've done with this model of an interpreter that you feed specifications to through these 4 documents is that if someone else has needed say an excavation module, we call these modules, right? If someone else has needed an excavation module or a survey module, you can start with what they did. That this is portable. We can we put all of these modules up on GitHub, which is a software version management thing that allows you to see a piece of software, or actually any kind of text. We use it for these documents, make a copy for yourself, and then do whatever modifications you need. And it's much easier to modify these existing documents, you know, and reuse them, as opposed to starting from scratch. So you've got to. There are two sort of separate on the device. There's the underlying, the sort of core FAIMS software, right? That's the interpreter, map rendering, you know, management of the various sensors and you know, camera stuff on the devices. There's that core, you know, software, and then there are the modules, right? And the modules are defined by these documents, which, you know, just to look at them very quickly, that define the schema, what your data actually looks like, what the user interface, the UI looks like, and then the logic that drives it. Localization is something else. I will talk about that in a few minutes, about what that does. So you feed these things into you know, into the FAIMS mobile software, and what the developers call it instantiates your project on the, you know, on the device. So that's so that's the basic sort of architecture of it. So the way that you customize it is by editing those XML documents. Adela, are you trying to get my attention to add something?
I would just ask whether how people feel about it. Are you clear on it, or is this confusing?
Yeah.
We realize that this is not. I mean, hearing this the first thing in the morning is not the easiest thing to digest. So I actually want to have a little experiment. I've been thinking about what metaphors I could use to explain the creation of the modules on your phone. And the one, after thinking for like weeks, because it's fairly complicated, I thought that it's like baking. The FAIMS app is your oven. It's got all the settings, as Sean says, you know, your GIS button, your fetch the picture from the camera and fetch the GPS from the GPS sensor. It's the oven. The modules, all of these different documents, it's like ingredients you would make a cake out of. So when you need to think is, what do you want in your cake? As you know, how am I going to do my recording in the field? And you tell us what the ingredients are, exactly the list, exactly the order they need to be in, the ratios, you know, the amounts, and you make a dough. And that's these 4 documents is the dough. You feed it into the oven, into the FAIMS app, and at the end you get a cake. And you know, at the end you can still do some embellishments to the cake. You can cut it, put cream on it, you know, sparkles, etc. But you basically have a product. You have the recording module. So that's about how you can kind of think about what the app is and what the module is and what are the defining, what's the definition packet, the documents that you need to feed it. Does that make it any more clearer? Yeah? Cool. Very good. Thanks.
Okay, no, that's a good metaphor. I hadn't thought of that, and that actually fits quite well with. I won't, you know, try to hide that. We are looking for ways to look. We expect that in the future we'll apply for further infrastructure funding, you know, but none of us know, you know, how much, or, you know, whether there will be any, you know, ARC infrastructure funding, you know, available in the future. So we're looking at other ways of keeping the project going, and again, this is an open source project. All of our software is readily available, but we're using a strategy that Eric Scott Raymond, one of the, you know, fathers of the open source software movement in the 90s and early 2000s, that you know, he wrote a very sort of, in some ways, hard-headed book about how do you actually make enough money, or, you know, have enough income off of open source software to keep projects like this going, whether they're commercial or nonprofit, or, you know, research or whatever. And his analogy was that you give away the recipes, but you build a restaurant that we will bake your cake for you if you you know, if you want. And that's what we UQ was you know, enthusiastic enough about this project that they made a substantial contribution to the LEAF application, and so that's, you know, and we're working now with Jess and Andy to, you know, on their deployments now, in return for that. So yeah, and in future, this is part of our sustainability model. That whenever you apply for grants for stuff like this, they want to know, how are you going to keep the project going in the future, and this is is part of that strategy. So does this basically make sense? Does anybody have any sort of questions about how the division between the underlying software and the module creation, how the modules are customized, or anything like that?
Could you get back to the last slide for a second?
Oh, sure. I just had one.
How do you get access to GitHub? Like, where is that?
It is Penny. You've got more experience with that than I do. You want to?
Anyone can get onto GitHub and use it for anything you like. If you're wanting to branch from our modules or our code, you just contact us and we can give you permission to do particular things. So you'd have permission to copy and then do your own stuff, not necessarily commit back to the main branch, but we could also give you access to that. So, but it's fantastic. GitHub is awesome. We'll be showing it a bit later on.
Right, and
for a bunch of things.
GitHub was originally developed for software, but now it's being used for everything. Like, the city of Chicago doesn't know where all of their bike racks are, right? And so they put up on GitHub a map that has, like, we know where half of our bike racks are, and here they are, and they're all pinned on the map. And then they just crowdsourced it, and they said, okay, everybody, if you find a bike rack that's not on the map, here's add it. Fork off of our document that's on GitHub, which is you just make a copy of it for that you can edit, and then you can go around and you can add all these bike racks to it by taking GPS points on your on your mobile phone, and then you do a commit request where you say, look, I've done all of this. Please merge it back into the main document. And again, this started for software code for teams of programmers to work together on software. Like, someone might be working on one feature, someone else might be working on another feature, and and then when they get their feature ready, they go back to the owner of the software and say, okay, my feature is ready, please commit it. Then the owner will sort of review their code and say, okay, this looks good, and then they commit it back. But yeah, this is being used by writers are using it now for collaborative writing projects. Chicago's using it for their to track where their bike racks are. There's all sorts of things that are being used this way that it's being used for now that go well beyond software. So it's reasonably straightforward, I think. So,
Can you just look back to the last slide for a second?
Mm-hmm.
Just
This one?
Localization. Okay.
Did you want me to talk about localization now? I can give you the rundown on it. Okay. One of the things that we're trying to do on the project is improve the compatibility of archaeological data. We want to encourage synthetic and comparative study. We want you to be able to take data from multiple projects, whether excavation, artifact-oriented surveys, whatever they are, and do the comparative synthetic work that archaeologists like to do. And to do that, you need to be able to map your data, at least to some extent, to a shared vocabularies, shared ontologies. Like, okay, what do you call a stratigraphic unit on your project? Is it a context? Is it a locus? Is it a spit? And a spit isn't quite the same as a context. So part of our project is to build an ontology for archaeological data, and this basically lays out what kinds of data you're collecting and what it is, and what each thing is, so that we may have a thing, if one project calls a stratigraphic unit a context, another calls it a locus, and another calls it an excavation unit, fine, we'll call it Bob, and we'll map all of these possibilities back, and we'll say that a context or a locus are equivalent to to Bob, and a spit is similar to but not exactly the same as. this is anyone who's done anything with metadata. We use RDF triples for the. I don't know whether anybody's interested in it, but there are standard ways of describing metadata and describing the relationship, between things this way. Penny, do you have a better way of? I don't feel like I'm doing a great job of explaining exactly how ontologies work in 5 minutes or less.
It makes perfect sense to me. The only thing I would say is that, talking about mapping to Bob, what we would like to do, and we're hoping to get done within the next year, is develop a proper ontology where you're not mapping to Bob, you're mapping to FAIMS.123, which means stratigraphic unit, and we'll have a definition for it. And then all your other aliases in your own module will be mapping to FAIMS 123, and in one module it will say context, in another it will say locus, in a third it could be unit, stratigraphic unit, SU. They all look different on the module, but what you're actually saving and storing at the back end is FAIMS.123, and then we'll have standard ways of exchanging that in. So you can export your table with basic codes that would be meaningless to anyone who doesn't know the FAIMS ontology, or you can have that export done in your own terms and your own language, and you can trivially change those terms. You can have 2 different modules in the same team. You can have your own translations on your own device. So one person can be recording in Spanish labels. They're still doing English data, but it's all been stored and saved at the back end. So it's just changing this superficial layer, which is what everybody, like when we had the workshop, we had the lithics people sitting in the room. We were all talking about the same thing but using different words, and it took a long time to get past the fact that we're talking about the same thing but with different labels. We're just separating the label from the underlying concept, and that's the guts behind it.
And Penny's done some research about terminology around historical archaeology, and has found that although on first glance it looks very different, that with a little bit of thought you can map, 70 to 80% of it against one another, and it's basically the same concepts, but everyone's using different terms. And so essentially what this is, we don't want to force archaeologists to use our terminology, because if we do, no one's going to use it. And this has been the fate of a number of these projects similar to ours. So basically, you can use whatever terminology that you want on your local device, and maybe there's 20 to 30% of what you're doing that is really conceptually different than what than what most projects do. And okay, maybe we can't map that 20 to 30%, but the 70 to 80% that we can map to shared concepts, we want people to map to shared concepts. And so what we did, in a technical sense, was we did an implementation on the mobile application of techniques that were developed in the 1970s for localization and internationalization. This is basically, if you go and you go to IBM's webpage or CNN's webpage or whatever, you see it in Australian English. That's because as opposed to seeing it in Spanish or Chinese or American English or whatever. And that's because they see where you are based on where your IP address, and then they will have maybe the where it says CNN is well, okay, that's a bad example. Where there's the headline of the day is like hash headline of the day, and it feeds into that today's main headline in whatever language is appropriate for you, and we've done an implementation of this on the device, so that you may see stratigraphic unit or SU or locus, whatever, on your device, but it's mapped to an underlying context of FAIMS.123 or Bob or whatever you want, or whatever we decide the core concept will be. We're leaning towards just arbitrary names so that we don't preference any one system over another and rub people the wrong way like that. But so that's what the localization does. It is also useful for what the original idea of localization and internationalization was, which is translations into other languages. So we have now had a couple of projects in South America that have wanted both Spanish and English interfaces for the app, and all we have to do is change this localization text document, and we can deploy in whatever language you want. So that's what localization does. And unfortunately, what we've been resisting ever since the beginning of this project, developing our own ontology. We did not want to do it. I think I even have the reason we don't want to do it somewhere. I bet it's way at the end. Oh, there it is. This pretty much sums up what happens. 14 competing standards. This is ridiculous. We need one universal standard, and then now there are 50 standards, right? But this is how standards development works. We've been resisting from the beginning developing a new ontology, but the existing ontologies for archaeology are generally built around the CDOC CRM, which is a cultural resource management ontology that was constructed from the beginning from the point of view of people who were working in museums and at archaeological sites, like ones that are already excavated and working at the Parthenon or something, right? And when you try to, so it's very much an end of the process. I have a bunch of artifacts sitting in a museum, and I've got an archaeological site that I'm using for cultural tourism, right? And and it's looking at it from that end of the process. And even though English Heritage has tried to turn it around and customized it for use for data recording, it's not really. It's very. We can kind of map to it, but it's not very effective as a way of thinking about your data when you're actually producing the primary data during excavation, survey, artifact processing, etc. Is that a pretty good way to explain it, you think, Benny? So we are reluctantly reaching the conclusion that we're going to have to build an ontology that's from the point of view of the field work, and then we'll map it to the we'll map it to the CDOC CRM later. Yeah, that's where we're at now.
Is kind of the main point of that with respect to the ultimate repository?
Yeah.
And so that people can search multiple projects and get the same concept returned to them in their own archaeo speak?
Yeah. And at least the repository knows that certain things are similar to one another, are identical to one another, similar to one another, and there's some nuance in it that you can. In the languages that describe ontologies, you can have something is equal to something else, something is in a hierarchical relationship to something else, something is similar to something else. There's a whole vocabulary of these kinds of things to tell you how concepts are related to one another. So a locus may be equal to a context may be similar to a spit, but not quite the same because it's an arbitrary depth unit instead of contextual, soil, color, and consistency type of thing. So you can describe all of that. But yeah, another part of the FAIMS system, which should be ready soon but isn't quite ready yet, is an Australian implementation of an online archaeological data repository that was originally developed by Digital Antiquity at Arizona State University in the United States. And you'll be able to take your data at the end of a project and export it to that repository, which we will. As soon as it's ready for public release, we'll also get it registered with the Journal of Open Archaeology Data. So I don't know how many of you are familiar with this, but they're not just in archaeology, all across the sciences, social sciences, a little bit into the humanities. There's a push to publish data sets now. Nature in the last year or so has started doing nature data, right? And it's in publications of data sets. Some of these data sets are related to full-blown papers in Nature. Other data sets are just important data sets that reach the threshold that Nature thinks they're so important that they'll publish them as a data. And these tend to be online journals. They're in the they're on the ARC Herdic journals list. The Journal of Open Archaeology data isn't yet, but I've told them to put it on there, and I've been rounding up support to let them know. But other data journals and other disciplines are. And basically what you do is you publish your data set online with a brief contextualizing article, say 3 pages or something like that, and it gets an ISSN and it gets a digital object identifier, and so it feeds into the incentive structures of higher education, of academia, so that we can get, credit for it, and so that it's readily citable and reusable by other researchers. So TDAR, the underlying software that we've used for our Australian archaeological repository, is already recognized by the Journal of Open Archaeology data, and it should be not too difficult for us to get our implementation of that, our Australian version of it, to be recognized as well. So part of this is to produce, in the end, these compatible data sets for synthetic, that support the kind of synthetic and comparative research that a lot of us want to be doing. I'm aware of the time. I'll just see if there's what else is in my thing in my presentation that is actually worth speaking to that hasn't come up already. I'm going to spare you the underlying. Penny, your picture didn't drop in.
It's in there. I think it's because you started before it's
okay.
saved.
It's okay. I will spare you the underlying data structures of our database. I will just say that what we've done on the device is that we have implemented a generalized database. It's a database that that can. If you imagine a spreadsheet, we've essentially taken all of the rows in a spreadsheet, right? The things that would be your row headings, right? We've taken all of those and they're sitting in their own table. We've taken all of the column headings and they're sitting in their own table. And then the intersection of those two things, the data that would be in any given cell of a spreadsheet, that sits in its own table. So there are 3 basic tables that the data sits in. And as you can see, you can customize this however you want. You tell it what the rows are, what things you want to record, what the columns are, the attributes that you want to record about the things that you're recording, and then the data lives at their intersection. So, look, if any of you are more interested in this, I'll talk to you about it at more length. But it is a generalized underlying data structure that allows you to customize the system without changing the data structure. We'll talk more about why that's important tomorrow in the data modeling section. But it is really the data modeling, and again, we're going to have a data modeling session tomorrow, so I won't dwell on it now. But it's really the modeling of your data that is what takes time when you're customizing these things. I'm sorry, did you have a question? Or are you? Oh, okay. And here's an example from the Andes Architectural Survey that it's thinking about your data in this, and I'll throw this out at you now so that you have something to think about for tomorrow. That if you want to record structures of late Inca, early colonial architecture in the high Andes, and you have structures and they have doors, walls, windows, and niches in them, do you just say, I have a structure, and a structure has 4 walls, a door, 3 windows, and 2 niches, and you just record it that way? Now, if you do that, you don't know what wall the door is in, you don't know what wall the windows are in. Do you care about that? Do you want to be able to do some kind of spatial analysis of these buildings to say that the doors are usually on this wall facing this direction, and the windows are usually on these walls, and there's usually, that niches and windows don't appear on the same walls? Do you want to do that kind of spatial analysis? Because if you do, this simple using a structure as a bag and dumping all of the other things into it, you can't do that. It precludes, and that's what I mean, that you have to think about what you want out at the end when you're designing what goes in at the beginning. So, we suggested 2 potential other things where you say, okay, a structure is made up of walls, and then doors, windows, and niches are tied to individual walls. So that's one way you could do it that does then allow you to do some, a great deal of spatial modeling. Or another thing you might do, these structures, a lot of them have shared walls, and they're like towns that grew together. So it's not always entirely clear where one structure ends and another begins. So it should instead the wall be the main, the principal thing that you're recording, and then later you group walls into a structure by adding them to a group. Look, we're going to talk more in more detail tomorrow about data modeling, and it's a particular way of thinking that, again, it's not something that that most archaeologists or most researchers of any kind are trained in, and it's a little bit of a it's a particular way of thinking about the data that goes in at the beginning of a project and how you want to record it to ensure that you can do the sorts of analysis that you want to do at the end. And that's when we get on the on Hangouts or on the phone with Jess and Andy, and we harass them about exactly how they want to record things, it's usually because we see a potential problem like this, that if you use, not worrying about the details of this too much right now, if you use Model 1 here, it precludes certain kinds of spatial analysis later, and you can't ever recover that, right? You're committed when you make that decision. So that when we get on the phone and we harass them, it's usually because we see some kind of a pitfall like this that they may run into. We'll have to show. We'll show you some of the. This is a few other features of the application. These are some we need to get some better screenshots. I guess the one on the right isn't too bad, but I think you can see that this is showing how you can do vector drawings of structures that are visible in aerial photography. Using the GIS functionality of the device. So we have one of the other things that emerged. I should have prefaced this by saying one of the other things that emerged from the stock taking workshop is that the one piece of software of sophisticated software that the most archaeologists use is GIS. Usually ArcGIS, some others Manifold and QGIS or GRASS or the other competing ones, but that GIS functionality was critical, so we invested quite a bit into that, and we are going to talk later soon about how the mobile data fits into a bigger data lifecycle. So I'm not going to dwell on that right now. I'll wind it down instead. But I would say, again, just if anyone in here is interested in developing field recording modules with us, the key is to plan ahead, to contact us early, to provide us with copies of your recording forms. On the one end, the recording forms. On the other end, the reports and analysis that an example of the kinds of analysis you do. Usually, this is in the form of a report or a paper or something like that. So that we can see both what you're currently recording and what you want at the end. You might, thinking about your workflows, and then we can talk to you about building modules. And this is something we'll talk about module construction later. At this point, in most cases, we recommend that you work with us to develop the modules. The University of Sydney is working on an adaptation of an online database that they have, where you can actually use their online database. It's called Hurist, as a kind of a graphic user interface to design our modules with. And right now, I would say it's useful for small and simple modules, not for complex modules. But also talk to us, because it is likely at this point, at least for certain archaeological activities, that we have existing modules that we've developed. Like our excavation module is getting fairly mature now. So, when it came to customizing it for Andy, it was probably 70% of the way there, 70, 75 for both Andy and Jess. Then we we did their customizations and fed a lot of those changes back into the core excavation module. And so we've had other projects approach us since then that we're able to turn around very quickly, because it was only relatively minor changes to this underlying or this core excavation module that we have, and a lot of them just changes to the localization file to change the terminology to what the people wanted. So planning ahead is key. That was one of the things I wanted to, I started this by titling the presentation, I'm in the field, send me your app, and this is somewhat an exercise in expectation management, that it's because archaeologists demanded quite a flexible and customizable application, there's a lead time for it, that is the effort that it actually takes to do that customization. So does this basically make sense? Does anybody have any questions about it? It doesn't work like most, I mean, it doesn't work like most apps do. Most apps are sort of simpler, and you go on Google Play and or the whatever it is for iOS. Sorry, I'm Mac and iOS illiterate, I'm afraid. You go on there and you download it from the from Google Play or whatever, and you install it, and it does sort of one thing, and it's pretty simple, and it doesn't require a whole lot of customization, and that's the app experience that most people are used to, and ours is somewhat more complicated. So I mean, I would expect, as the power of mobile devices increases, which it's doing, very, very quickly, I would expect more of these sorts of robust and apps that look a lot more like desktop software, because the mobile devices are about, they have the power that desktop computers did like 4 or 5 years ago. I mean, that's about where you're at right now, and so I'd expect more of this in the future, but it's still not sort of common experience right now. Okay. I've run us a little bit over here.
So most of my queries are with respect to the future, and you have a sustainability plan that seems very sensible, but with respect to changing hardware and changing mobile platforms, different versions of Android coming out and that sort of thing, what kind of, I know we talked about that on email, but I'm sure a lot of people are probably wondering the same thing, so I just thought I'd ask you to address that question. With respect to kind of the long-term longevity of this project and getting involved in it now, and also with respect to our ability to access you guys forever into the future as needed. Because under the current model, it's quite heavy on the interaction side of it, and that's great while it's under the grant, but in the future, I don't really know what that could become, I guess.
Right. Yeah. No. This is a concern of ours as well, because I mean, I think that the history of other projects that have done this is that when the initial project sort of winds down or the grant ends, they sort of disappear, and that's one of the motivations that we have of putting the software out as open source, developing partnerships with other major information management initiatives in archaeology around the world. So we have Julian Richards at the Archaeology Data Service in the UK, which is probably the single most successful archaeological information management endeavor in the world, because Julian has managed to get the ADS designated as the place where all archaeological data sets that are produced in the UK must be deposited there. So he's set as far as his the sustainability of that project. But we're developing partnerships with him, with the University of Chicago, which I mentioned their NSF grant. They run a piece of software called Ochre, which is an online data management, refinement, visualization platform. With Open Context, which is out of Berkeley, that's a publication platform for archaeological data. TDAR, that's a repository platform. Later we'll talk a little bit about the difference between a publication platform and a repository. But we're trying to develop, we're putting our software out there and trying to develop these relationships so that if our project, doesn't get any funding and we all get run over by a bus or something like that, that somebody else will pick it up because they see that, I mean, if you're not counting our, management or administrative time, we probably, if you just count software development, the mobile application to date has probably cost $500,000, to develop it, right? Some people look at it and are kind of shocked. It costs that much money to do this. It's, but it is this underlying, it was difficult. I mean, the GIS was pretty hard. Like that took some serious money to get, offline mobile GIS that has the features of. It's also a lot of applications for Android and iOS are for information or they're for consumption, not for production of information, right? And so a lot of the existing mapping software, it's not it doesn't have the features that archaeologists need for things like having layer management, having being able to render arbitrary geotiffs, satellite imagery, whatever, being able to do vector drawings. Soon, hopefully, with our being able to do things like mathematically constrained polygons. Like what I mean by that is, like our project in Bulgaria, instead of using what's more common in Australia, which is a transect and site survey, we use a Mediterranean total coverage survey, which is line up 5 students, 15 meters apart, walk them across the landscape, and every 15 meters read off everyone reads off the count of the ceramics or other artifacts that they've found. Mm-hmm. So I need to be able to stand here, push a button, and say, give me a 25 square, give me 25 squares, 5 wide, 5 long grid in front of me, and then we walk along, and every 15 meters we read off the counts, and then populating those. We're working on this kind of mathematical generation of polygons in front of us, right? This is the sort of thing that most mapping software for mobile devices is, I'm here and I want to ride my bicycle someplace else, or I want to use OpenStreetMaps to see where I am and find out where the nearest grocery store is. It's this sort of thing. It's data consumption, not data creation. So building something that allows this kind of data creation was expensive. Building the idea that it's an interpreter, that it's not a fixed just a fixed data logger, but that you can customize it, that was expensive. Doing something that allows you to do more, in database speak, something that allows you to do relational data, and we'll talk a little bit more about this tomorrow in data modeling, something that goes beyond a spreadsheet. A spreadsheet's 2-dimensional. You've got column headers, row headers, and then the values in it, but something that is essentially 3-dimensional. Imagine a bunch of spreadsheets stacked up on one another. Doing that is more difficult. There's something called the Open Data Kit that Google and the University of Washington developed that's used for a lot of ethnographic work and stuff like that. That we looked at, and it's open source, so we used some of their source code for ours, but it didn't allow the use and manipulation of relational data. It was only flat data, and if that don't panic if what I just said makes no sense to you at all. We'll explain it tomorrow. And why it's important to you. These things were expensive, but we've now invested in it, and we're hoping that, like has now, thankfully, I was a little worried when I first heard about this NSF application. A lot of the other leading players in the United States and UK, at least, know about us, and I think that that it's likely that they will pick up the open source project if it falls over here, right? And the idea in the medium term is to get as many people using it as possible in as many different places as possible, so that it does go on when our own grant winds down. So that's a sustainability issue. The hardware and software issue. The hardware is just getting more and more capable all the time. I mean, there's new sensors are being added to the device. I mean, even this one, something for survey that would be very useful. This has a barometric altimeter in it, and if I calibrate it, I can get my elevation to within a couple of meters. So, because GPS is notoriously, even differential GPS is rather poor at elevation. It's much better at lat long, than the X and Y coordinates are better than the Z coordinate. But with a barometric altimeter that's got an accuracy of a couple of meters, and that's I didn't even know this had one when I got it. It's also got a magnetic compass in it, so that's much better for like bearings and stuff like that than a GPS-based compass. So they're and new ones. They're adding new sensors all the time to these things, and the hardware is becoming faster. The amount of RAM goes up every year. The amount of onboard storage goes up. So the hardware is only getting more and more capable. The software, Android is definitely here. It's here to stay. They've got the biggest market share of any mobile system now, and it has stabilized a great deal. Like the difference between Android 1 and 2 and 3.2 and 4 and then even like 4.1 or 4.2, there were pretty significant differences. But after about 4, it's changing less. And in fact, Google seems to have changed their strategy somewhat, because what Google found, because Google's developing Android for use by lots of different manufacturers, when they do a major point upgrade on this, go from Android 3.2 to 4, and they do a major point upgrade, a lot of hardware vendors, Samsung, HTC, whoever, won't pick up that upgrade, and so the end users don't see the improvements that Google has invested in. And so now they're releasing fewer point upgrades, and they're doing feature upgrades through Play. That Play isn't just a way that you get online and download apps. It actually does a bunch of, it is, it's sort of got its claws deep into your phone, right? And they can do a lot of feature upgrades now by just pushing out new versions of Play instead of doing a point upgrade. So point upgrades are coming less often. They're less important. And things are stabilizing now. Like, it's not changing as quickly as it used to change. So I guess I'm pretty sanguine about Android as a development environment, and I do think this came up with talking about the total stations, that hardware manufacturers of total stations and GPS units, especially like differential GPS units, are using quite antiquated software. It's often Windows Mobile 6, Windows CE. It's this old software that's not going to be supported by Microsoft indefinitely. I mean, Microsoft's already cut off support to Windows XP, and finally, well and truly, they did. And CE is as old as XP is. Windows Mobile 6 is only a little bit newer, and it is. I think it is likely when those hardware manufacturers do finally, are forced to embrace a modern operating system. I'm not sure they'll go with Windows 8. Because Windows 8 is not, and let's say it's not taking the mobile world by storm. Does anyone in here have a Windows phone? Yeah, I thought so. Yeah, that it's really Android and iOS. That's where the action's at, and they may very well develop for iOS because it is much more sort of, it's controlled in some ways that make it somewhat more predictable, but on the other hand, it's also more closed, and it's an expensive environment to work in. So I think that it's likely that hardware manufacturers for sort of if we're talking about external devices like total stations, differential GPS units, those sorts of things, that they'll at least support, if not go entirely to Android in the future. So I don't know. I guess I'm pretty comfortable with Android as a development environment.
I wanted to make a point about sustainability in terms of us. Your question was that you realise the amount of time that we put in and the discussions that we have. First of all, we all hope that will be reduced in time. The more modules we have, the easier it will be for users to go in and pick and choose between what they've got. The other thing is there are commercial services that are interested in what we've done and would be able to take our open source software and develop it, or simply use it as is and develop custom modules for you or for anyone else. They're already doing that with other government-issued modules and things like that, working with Indigenous communities, and there is actually a growing commercial, small, a growing commercial industry where there's those support services for translating between researchers and techies, because that's what we do. You know, that's our bit in the middle, which is difficult to fund and get grants for. I just wanted to make that.
So yeah, we're trying to get. I mean, the key to success is going to be to get as many people as possible using it, and as many other distributors besides us. That also, you know, I used the analogy earlier that we're giving away the recipes, but we opened a restaurant. We want other people to open the restaurants using the same recipes, using the same software as well. And that's those two things. They both contribute to sustainability directly, and then also that the more people who are using it and the more uptake there is like this, the more likely it is that, you know, provided there are, you know, infrastructure grants available in the future, that we're more competitive for them, because we can say, look at all the projects that are using it. Look at the, you know, it's had a commercial in, you know, the ARC seems to love this. You know, that look, these commercial companies are also using it. So that's part of it as well. So, and we are, you know, we are likely to, we're going to try to budget for another stock taking workshop at some point, try to keep in close touch with the archaeological community. I mean, this year it's largely through deployments, because we're doing your deployments here. We're doing a series of deployments at Flinders. They're another one of our big supporters. We're working with Nicholas Stern on her Lake Mungo work to do a deployment there for next year. What else have we got? You know, we've got quite a few projects like this in the pipeline. A couple of we've started getting commercial work as well. Consultancies who want to do deployments. I think we've got at least two who are, you know, at the stage where they've started sending us their documents and having us scope their you know, their work now. So. Yeah, I'm pretty confident about the next 2 or 3 years, and then after that, you know, it is a little nerve-wracking, but we think that we'll be around, or someone will be around who's continuing development of the software. So is that basically, have we answered your question?
Yeah, yes, and I'm probably going to catch you later and talk about a couple of other details of some other like ideas and stuff, but I won't bring it up.
Okay. As you said, our schedule was more or less a rough guide rather than a hard and fast rule. So I see we've gone over, but it's often the questions at the end of these presentations that are the most useful.
Occasionally.
Yeah, why don't we take a break for like 5 minutes so that?
Yeah, sure. I'll just actually stop that.